So welcome everybody in this fourth webinar of the BeyondXR Cluster. I am John Soldatos, company Novax XR 5.0 project. And today we are hosting some excellent speakers from different projects of the cluster, XR to Industry, Master XR, Cortex, Gen AI 40D, and Transmix XR. Without further ado, I would like to move to our first speaker, Ms. Elena Vargas. Prior to that, just some housekeeping rules. So please try to keep the time. It's 15 times for the presentation, including one question. We can have more questions in the end. Keep your microphones muted unless you are speaking. And also you can ask your questions at the end of each presentation or even at the chat. Thank you all very much for joining. Thanks, special thanks to the speakers for their contribution and willingness to contribute content. Elena, the floor is yours. As I will ask the other speakers, please feel free to introduce yourself, introduce your project, and proceed with your presentation. Thank you.
Okay, thank you. Okay, can you can
Yes,
see
we
the
can
presentation?
see your presentation. Yes, please go on.
Yes, perfect. Okay, well, hello everyone. I'm Elena Parra. I'm working in Universidad Politécnica de Valencia. This methodological proposal that we present in this presentation is related with XR to Industry project, a European project related with extended reality and learning. And today we'll talk about how technology, specifically extended reality, is transforming the way we learn, what makes a learning process effective, and how can we personalize it for each individual. So let's take a look. Before talking about extended reality, let's look at the main types of learning. In this case, there are different types of learning and therefore different outcomes. For example, experiential learning, which is based on practice and reflection. This type of learning is usually in the case, we're learning to drive. Another type of learning is theoretical learning, which is based on concept and reading. It's a good example of that is when we learn history or philosophy. And we also find collaborative learning, which is learned through interaction with other people. Finally, is the autonomous learning, in which the person directs their own learning. For example, when you learn a language with an application like Duolingo. Now, it's important to emphasize, as Cole does in his model, that learning is a cycle. It's not enough to receive information, we must apply it. This model presents the Kolb cycle through which all learning occurs. This cycle have different phases. The first of them, said me that sorry. Okay, perfect. Okay, it's important to different the different phases in the Kolb cycle. In this case, we come to the concrete experience phase, as this is the first phase of the learning. This consists of performing an activity. Let's take an example of a virtual reality flight simulation. After this phase comes the reflection phase. That is analyzing what happened. And our example is the errors in this simulation. After these phases comes with the conceptualization. Consists of generation ideas or improving strategies. And finally, active experimentation. In our example, is how applying this knowledge in new situation when you fly in the real world. But as we said at the beginning of the presentation, we don't all learn the same. Technology allows us to adapt this content to each individual. In this case, the Campbell model considers three key factors to be able to personalize this teaching or this learning and adapt to each student. These three factors, the first of them is cognitive, related with the processing information and memory capacity. The other one is affective, is the related with the emotion that the user feel during the experience of the learn. And finally, the motivational, linked with the student's expectation and goals. An example of this is how through artificial intelligence, the difficulty of content of a course can adapt to the student's performance during the experience. Okay. According to this model, these factors influence content adaptation, but to do so, it is necessary to understand the level or the specifically characteristics of these factors in each student. There are different tools of measuring this difference between the students, but we will focus on the most implicit one. That is those that cannot be consciously modulated by the students. So we focus, for example, in the eye tracking. Is this metrics is be able to assess the attention and comprehension of the content during the experience. Other one of metric, implicit metric, is the voice. These metrics provides important clues such as emotional aspect or comfort with the content. And finally, the movement or the reaction during the experience, because it's very related with decision making and give us information or significant information about the behavior and the feelings of the users. Therefore, if we adjust the difficulty based on the student's emotions and processing style, the ability to personalize and adjust the difficulty of the exercise is greater. A practical example of this would be modify the difficulty of some exercise if we based on the cognitive load during the experience. For example, day tracking gives us information about this cognitive load, and we can change the exercise and the learning content. As we recall, the main goal of this presentation is determine whether technology improves learning. To do this, we need to compare. Let's take the example of a surgeon. If we use a virtual reality, for example, the surgeon can perform an operation safely. However, if we use traditional learning, this learning is from books without the opportunity to experiment. Therefore, we see that the technology provides greater interaction and consequently greater retention, also allowing for real-time simulation to practice this skill. Okay. So each person processes information differently, which is why we choose the appropriate technology. In this case, it's very related with the information processing style. The type of technology that we can adapt to this type of processing is very useful. For example, if the processing style is sequential, structured online courses will be most useful to this type of student. If the processing style is more visual or spatial, we need to put this learning in a virtual or augmented reality context. If the processing style is auditory, perhaps a podcast and voice assistant is most appropriate. And finally, if you have a processing style related with kinesthetic, simulation and virtual labs will be adapted to the learning style. How do we use all this in real life? Okay, let's take a very specific example. In this case, leadership training. Sorry. Sorry. Oh, sorry. Okay. Sorry. In the example is the leadership training. It's a difficult component to learn because you have more soft skills that is difficult to learn in traditional methods. So to do this, we understand that with the help, for example, with a virtual reality, we can simulate meetings and improve specific communication and decision making. So we extract important information and we can adapt the content. If we compare this with a traditional methods, we can see improvement in decision making and increased confidence for this individual in real meeting. Okay, this is how technology combined with learning models and personalized student assessment can make training more effective and adapted to each individual. I present this video. Oh, sorry. In this case, we can see a virtual reality adapted to a learning related with leadership. In this case, we extract implicit metrics related with a tracking and with voice, and the content on the environment can adapt to these metrics. We try to understand the processing style, and in this case, the response of the avatars adapt to this style. The interaction in this case is with voice and with interfaces, but we put some intermediate sorry. Oh. We can adapt the environment, and we put intermediate tasks related with games. In this case, the use of gamification is very important because we can extract implicit metrics of decision making. So finally, to close this presentation, I present three key ideas. The first of them is technology enhanced experiential learning. The second is the personalization of the learning is very important to extract a successful training, and choosing the right technology helps us to optimize this learning. So the future of education isn't just digital, it's adaptable to each person. It thanks to technologies related with artificial intelligence, gamification, and extended reality, we can learn more effectively. So thank you very much. Sorry because I have some problem with my voice, but
thank you, Elena. The presentation nevertheless was very clear. Are there any questions to Elena? Usually it takes some seconds till there is a bold guy to ask a question. Elena, what I wanted to ask is twofold. First of all, to which groups is this applicable? So you presented managerial training in the end. But this is, for example, a method which is applicable just to adult learning or also to students. And second, is there a dynamic way to create the adaptive content, or it is a thing where you just gather data, then you see how you personalize, and then you develop the content for it? Or is it more, automatic, adaptive way you are working on? That you gather the data and then I give you another game or I give you another visualization. This is my question.
Yes. Okay. First of the question is this type of content is very related with a specific population, but finally we try to design and to develop technologies that we can adapt to all the population, because finally we analyze the general behavior. Very related with soft skill, so related with empathy and critical thinking. So this type of learning is very useful for many situations, not only to leadership. So we can adapt the context to many people in many different states. The second is, in this case, we have some change related with in real time with the extraction of these implicit metrics. For example, if the response of the students is more emotional, the avatars responds the different way if you say something more emotional. So we try to adapt to this real time.
Thank you, Elena. Fridolin, one quick question before we go to Konstantina.
One small tip or comment. I know that Chris DD from Harvard is currently trying to gather like-minded people that are interested in authentic negotiations that have to do with leadership skills. In particular, what he wants to do is negotiation skills. Kind of, training people to do the art of the deal, I guess, just better. If you're interested in that, he said he wants to run a workshop at the iLearn Immersive Learning Research Network conference in the States in a couple of weeks. Might be interesting to reach out to him if you have an interest in that. My question was more about the eye tracking. You mentioned quite rightly that it can be indicative of cognitive load. But as we now are using more and more gaze interaction for interaction, this is affecting how we can use eye tracking, right? Because it tracks all this user interface interaction in a very artificial way and is no longer the natural interaction of what you're really interested in, what you're focusing on, whether that's something in the user interface or whether that's something authentic in the actual virtual or augmented reality. So I was wondering if you have a thought on how we can control that in the future and still make use of both, or
Okay. Related with cognitive load, we put some areas of interest in the environment. With augmented reality is more difficult because it's more complex. But in this case, we put some areas of interest. So we only analyze if you have your focus or your eye focus in some areas in the environment, not profound or intense analyze of this type of metrics. In this case, we use more voice because we can adapt more the environment with the voice. But the eye tracking gives us important information about, for example, cognitive load, but not in real time, because this example we have many times 10 minutes, and after that the user or the students can analyze own behavior. So in this case, the tracking is not very important for us. So okay.
Thank you, Elena. Thank you all. We can have maybe more interactions in the end. Konstantina, Please, the floor is yours. Take the time to introduce yourself, introduce Master, and give your presentation. Thank you, Elena, for the presentation.
Thank you.
I hope you can see my screen. Hello,
Yes,
everybody. Okay, I'm Konstantina Salajani. I have background in mechanical engineering, and now I work at Teaching Factory Content Center. We are one of the partners of Master project. Master is for mixed reality ecosystem for teaching robotics in manufacturing. And the presentation today will focus on the evaluation of the XR applications and the framework that we are currently developing in Master project. Just to have an overview about Master, Master objective is mainly to boost the XR ecosystem for training of robotics in manufacturing industry by providing an open XR platform. This platform integrates some key functionalities. We call them pillars in our project, which are mainly focusing on creating safe robotic environments and programming robotic applications, and focusing also in the advanced interaction mechanisms that are used in this XR application. Master will also deliver training content that will be related to robotics in manufacturing industry, and through 2 open calls, we'll finally integrate third-party contributions. I will also talk about these calls at the end. The main key points to keep is that the first open call that has been completed will integrate the different contributions in technical aspect, the different technologies, and the second one that will be launched in a while, in a few weeks, will focus on the enhancement of the education and the training content related to the robotics in manufacturing. As an introduction to the XR applications for training in industrial environments, the main characteristic that we could see is that they are a digital replica of the workplace. They can provide the hands-on experience to employees without interrupting the production, which is quite important. And it's not only time related time consuming, but also leads to less resources, to decrease the resources consumption. We have also an accident or failure simulation and can train the employees in different situations. And finally, it can be a learning procedure for new employees or for existing employees in new procedures, or for maintaining the different skills of employees. The main impact would be to increase the productivity and the quality of the processes, to reduce the required resources for training and the upskilling and the empowerment in general of employees. The existing examples of virtual reality applications in the training in industrial industries, in the industrial field, are related to the health and safety, to the maintenance of robotic and automation systems, and mainly to the design of workplace layout. Some indicative existing evaluation tools that are commonly used are the system usability scale, the NPS score, as we all know, also the NASA TLX, and finally some quizzes that could be used for assessment of learning of the different trainings. The vision of the evaluation framework that has been is under development in the Master project is to evaluate the XR industrial training applications comprehensively, to see the impact in different point of views. It's also the objective is also to create a standardized procedure of evaluation using existing tools, not to invent new tools, but to combine them in a proper way to have this comprehensive evaluation. Also through the evaluation of the applications, of the XR applications, we aim to provide the necessary feedback to the developers for further improvements and further developments of the XR applications. This will also lead to increase the users, the trainees' trust in the virtual reality and in general the XR training applications, and to empower human centricity of these applications. Finally, it would be a good opportunity to promote these technologies and to enhance the integration of them in the industrial field. The evaluation framework is a multi-perspective framework that aims to have this comprehensive evaluation and consists of 7 aspects. The first one focuses on the trainee's profile, and what it's trying to do is to identify the features of the target groups in order to address their needs and to enhance the inclusiveness of this framework. What is mainly evaluated or identified is the level of familiarization of trainees with different technologies integrated with industrial environment in general, and the specific procedures that could be related to also to the robotic application, as we mainly focus on mastery. Finally, at this point, we also identify actually the educational background of each trainee. The next point that is being evaluated is actually a recording of the features and the functionality of the XR environment to ensure that the users have a good experience and it's not it doesn't affect the general application. We are talking about the frame rate of the application, the latency that may exist, the rendering quality, the navigation comfort, and the accessibility features that are integrated so as to ensure the inclusiveness of the environment. The next one is the integrated technologies. Actually, here we evaluate the integrated technologies to ensure user acceptance and to leverage the training process. We evaluate here the usability of the different technologies that are included, also the interaction methods with the system, the ease of use of the robotic and automation features if we are talking about the master project and the robotic applications, and one also which that could be indicatively shown here is the time required to perform a robotic application in VR and compared to the real world application. Evaluating also the learning process and the provided material could also affect the general experience of the user, and we are talking about the level of assistance, the level of guidance that exists in the different applications and the different scenes, training scenes. We're talking about the quality and the quantity of the learning modules, and how understandable could be the language that is used inside the application. Finally, the experience can also be evaluated as an overall experience using the methods that I mentioned before. We evaluate the user acceptance, the ease of use, the safety feeling, and the workload, the mental mainly workload that could be raised here in such applications. The skills and competencies that are acquired during this training process through XR can also be evaluated through a learning score or through the completion time, and also I have comparative result about the level of familiarization of operators, of trainees, of users, the familiarization of them with advanced technologies before and after this training. Finally, ethics are also an important part of the different applications, and the evaluation here mainly focuses on ensuring that we have accessibility, data privacy, there is no discriminative language used or graphics inside, or the way of guiding the operators, the trainees inside the working environment, as well as compliance and a respect to the skills diversity that may exist in the manufacturing field. The first experiments that we had in master were performed with the preliminary results of the developments, and were focused on the 3 pillars of master. The first pillar includes focuses on the health and safety, and includes scenes that are introductory to an industrial robotic cells element. It would be an introduction to the different movements that the robot can perform, or a collaborative robot can perform, the different reactions to the safety zones that we have in an environment, an industrial environment, and how the user can violate these zones and check the feedback of the system. The second one, the pillar, the programming by demonstrator, actually has 2 scenes that evaluates that provide a training related to how to approach, how the robot can approach the region of interest, and how can perform precise positioning of some components if we're talking about an assembly. And the last one, the third pillar, is related to the interaction mechanisms that are being developed in the context of master. And there, the gaze-based menu navigation in VR were assessed. These were a comparative evaluation between 2 menu layouts and 3 different interaction mechanisms. And performing these experiments, a lot of feedback was acquired, and this feedback could also provide important insights for the developments and for the evaluation process as well. So more or less, this was the first experiments. Summarizing what I said before, this evaluation framework actually tries to evaluate comprehensively in a broad way the XR applications, and not only focusing one part. And some main benefits, as I said before, was to create an holistic evaluation and to create a standardized process that could be used for further usage in different XR applications, and also to create a way to transfer this feedback to the developers and the future developers as well. As I said before, the master project has in general 2 open calls. The first one is closed now, but the technologies are being integrated in the master platform that will be at the end of the project will be an OpenXR platform. And the second open call, which will be announced soon, in the next weeks, is focused on the validation of XR technologies in the learning environments. And it's an open call that focuses mainly on the enhancement of the training material and the content inside the OpenXR platform. You may visit our website for more information. That was all from my side. Thank you very much for your time.
Thank you very much, Konstantina. The next speaker is Narek, but I would like to ask, are there any questions to Konstantina about the different ways they personalize and adapt extended reality training in industrial environments? For me, Konstantina, it was not very, I don't know, very clear. It's early. What were the outcomes, right, of the experiments, right? What did you really measure there? You measured the technology effectiveness, the learning process. What did you measure in the last three experiments, which are, I understand, different settings and different modalities there, right?
They are different pillars, but we mainly keep the main format, the main structure of the evaluation framework. What was the outcome of these initial experiments? Actually, was the technical aspects that the developers should improve and to evolve in their system, and the usability assessment by the users, how acceptable was from the first users of the system, the different parts of the system.
Okay, and you compare this despite the technology is different, right? The pillar, right? You call it pillar, right?
We call it pillar, yeah.
Okay, thank you. Are there any other questions to Konstantina? If not, thank you very much, Konstantina, and we can move to time for Cortex, time for Narek. Please feel free to introduce yourself, your project, Narek, and give your presentation.
Thank you. I'm just trying to share my screen at the moment.
You can find the button on the toolbar at the bottom, right? Share
yes, but it says connecting and it's not doing anything.
I can share your presentation if needs be, but it's better that you do it. Right?
Yes.
We can see
I
your
believe it
presentation.
should.
We can see your presentation now.
Okay, perfect. Okay, sorry for the delay. I'm Narek Minaskan from German Research Center for Artificial Intelligence, DFKE, and today I will be presenting our project Cortex 2 to you. Let's give a little bit of information first about Cortex and what it is about. Cortex stands for Cooperative Real-Time Experiences with XR. We are a Horizon Europe project with a duration of 3 years, 36 months. We have a total funding of 8 million, and from this 8 million, 4 million is dedicated to FSTP projects. We have successfully launched already 2 open calls. We have funded 30 projects within these 2 open calls. Our project is going to end soon by end of August, but we have already achieved, I would like to say, a lot during the lifetime of the project. So let's go a little bit further and talk about our initial idea and when it started and why we decided to go with Project Cortex. Well, we all remember what happened during COVID. Yeah, people moved to remote working, and there were issues. Sure, there were lots of tools around like Zoom and Skype and so on. But these tools were not, let's say, properly equipped with the necessary equipment for, let's say, remote working in professional environments such as factories and basically environments such as that. So in our project, we decided to look into these problems and try to build tools to address these problems for remote working. There were challenges in our way, basically how to gather basically the necessary, or let's say the minimum amount of requirements for building such tools and make it available to XR environments. I mean, for XR, it's not just like an augmented reality or virtual reality tool that people use, but people need to be also be able to collaborate with one another in real time and in 3D. And this opens up, let's say, a Pandora box with quite a lot of challenges. And our goal in Project Cortex was to address these challenges sufficiently enough so that we can enable people to work together in an, let's say, collaborative 3D environment. So this said, our user story basically started with the, let's say, the picture on the right side. We were imagining that in a work environment, 3 people need to, let's say, work on a certain problem. One is already located in a factory. The other one is, let's say, a supervisor and they're working from home. And the other one is, let's say, on the train and needs to supervise both of them. The idea is whatever solution that we are developing needs to be able to run on, let's say, multiple devices, and it should, let's say, support different types of clients and different type of services needs to be available to these 3 different individuals so they can successfully work together. Let's say for the devices, we were targeting our normal desktop PCs that we are all using, smartphones, tablets, head-mounted displays. And with the clients, what we are building on the front end, let's say, we chose Unity and WebXR, and the reason for that is Unity provides, as a game engine, a solid foundation for 3D programming and for XR development, especially with the introduction of OpenXR. And WebXR also allows the usage of OpenXR, but on web browsers, which makes it available to people who would like to use PCs to have this type of services available to them. And on top of that, we also have to utilize, let's say, artificial intelligence technologies to enrich this kind of, let's say, interactions. For example, a 3D reconstruction, that is, how do we present the environment of, let's say, the remote worker in the factory to the supervisor who's working, who knows, maybe 1,000 kilometers away in the home, and they cannot have access to, let's say, this remote location, but they need to know, to understand what the environment looks like or what this specific device looks like. So to, let me put it this way. In our current tools, or let's say the tools that we normally use, we always have access to, let's say, video, camera, voice transfer, and then file transfer. So our idea was, how can we export these kind of technologies to, let's say, an augmented reality-based video conferencing system or an XR-based video conferencing system. This means that we should have all the, let's say, classical technologies available to us. That is video transfer, audio transfer, file transfer. And on top of that, we have to create new tools which can enrich this experience, this kind of communication, this collaboration in 3D. For example, if we are working with IoT devices, we need to have services that enable IoT interaction and, let's say, data reading and representation. We have to be able to do some part of, let's say, anonymization. For example, what happens if we want to have a video call, but we do not want to show, let's say, the full face or the face of the person because it is recorded, or for some reason, or for some ethical reasons, it is not allowed. So what needs to be done there? What if we have, let's say, documents that we want to share, and let's say we need to have a service to analyze these documents, and then the service needs to be able to answer questions about the document that is shared, let's say meeting notes, documents about technical devices, and so on and so forth. And to that end, what we did in the project was to create solutions that, let's say, support augmented reality and virtual reality teleconferencing in a way that it was, let's say, easy to use. And let's say, in each of these experiences, we were able to integrate the services on demand. That is, if these services are developed separately, but for a certain experience, the users can choose which one to use and which one to integrate in their specific work environment. To actualize this in our project, we defined the 3 main pilots, or let's say use cases: industrial remote cooperation, remote technical training, and business meeting. And let's say, just going to give small summary of the pilots. The industrial remote cooperation is, let's say, a factory settings, and two people need to work together to solve a problem. This requires them to have a spatial understanding of the industrial environment. So the services that, for example, are used there are 3D reconstruction and real-time 3D collaboration. That is, these two can work together in real time in 3D, and the augmentations will move around, and they can talk to one another to solve this certain problem. Our second pilot, remote technical training, is basically a virtual training center. You have a trainee and several, so you have several trainees and, let's say, a trainer, which, for example, in this example on the right, is about how to, let's say, work with an excavator. And the idea here is to present the virtual elements in real life precision, so that the training is seamless, it's natural. And our last pilot is about business meetings, which is, let's say, just like a call that we are having right now, but in full 3D, and let's say with services that are capable of summarizing voice and documents and ask and answer questions. To enable our, let's say, communication, our partner Alcatel provided Rainbow, which is a unified communication service, which brings service technologies such as video call, chatting, and all the voice interactions that I mentioned to the table. So basically what we have done is we have used their infrastructure, the APIs that they have provided, to enable this communication. So imagine like Skype call or a Teams call, but the European version of it, because it was developed in Europe. And basically we have used this to build the Cortex framework. An example of the services that we have developed in Cortex, for example, the 3D reconstruction in terms of representing the environment. This should work in real time. Of course, by real time, I do not mean that this reconstruction is going to be available on demand, let's say in 5 seconds. But the idea there is that someone can use their mobile phone, take a few pictures or sequence video, upload it to the service. The service, let's say in 20 minutes, will give them back the reconstruction of the area. For the anonymization, we have, let's say, an instant video avatars is maybe the wrong name here, but rather we call it VCAA, which is basically compressing the video transfer, but it replaces the facial movements with an avatar of your own choice. On top of that, we have conversational agents and semantic interpretation. As I mentioned, that let's say if you give it a certain document, the document can be interpreted, and then it can provide you answers to the certain questions or add entries to the document based on your demands, let's say. And on the other hand, we have IoT devices also integrated in our framework, where, let's say, if necessary, you can ask for certain values of different IoT devices, temperature, humidity, and they will be presented in this 3D collaborative system. With that said, that was my presentation. Thank you, everyone.
Thank you very much, Narek. The next presentation is from Epaminondas, but in the meantime, as Epaminondas is preparing, I would like to ask if there are any questions. What would you like to ask Narek about Cortex? I think it's really a challenging problem, right? So I would really like to understand, maybe, I'm going to read some more, right, in the website, but what is, so I understand that you take Rainbow as a backbone, right? This
Yes.
solves you the challenging problem of real-time communications, right?
Yes.
And I guess this requires a 5G network, right, for the immersion, or it can work and
any kind of internet connection would
any
work,
kind of internet
basically.
connection.
Yes, like one side can be, yep.
Because this remote collaboration, it is an ultra low latency type of application, right? I would call it a typical 5G application. And then on top of this, Cortex is building all the modules that you presented, right?
Exactly.
Like the avatars, like the scenes, and so on, right? And
Exactly.
I guess you've got also some technical building block to address the interoperability, to address the context modeling. Am I right?
Yes.
Trying to understand what's happening behind the scenes, to implement such a complex project.
It was quite challenging because we had to think in such a way that whatever we are building needs to be interoperable. So it has to work on HMD, it has to work on PC, it has to work on tablet. It has to be, let's say, operating system independent, Android OS, Windows. But the idea there is the underlying technology, let's say Rainbow, whatever they're using, let's say WebRTC technologies, they already run on these systems. And what they provided us is basically that backbone, that kind of APIs that we need to extend to XR development. And it has been working very well, I would like to say. Yeah.
Rainbow is a commercial product, right? I guess it's not.
Yes. Yes.
Okay, clear enough. And thank you very much, Narek. I don't see any other questions. If we have time, we'll see in the end. Epaminondas, the floor is yours. 2 projects, so feel free to introduce yourself and introduce each one of your projects and deliver your presentation. Thank you.
Great, thank you very much. Hello, everyone. My name is Epaminondas Kotavelis. I'm a research project delivery manager at Connectable, and I also have a background in education. Today, I'm going to speak to you a little bit about 2 of our projects, HECOP and GenAI for ED. And I will have we will briefly discuss a little bit about the future of learning, how XR and AI are reshaping education, and then we're going to focus a little bit and mention some specific examples from hackathons and AI for ED. First of all, before I continue, I would like to also give a few words about Connectable. Connectable Technologies is a software development company which was founded in 2013. It specializes in AI, machine learning, IoT, and big data. We have headquarters in Ireland and offices in Greece and the USA. And we provide custom software solutions, business optimization, and digital transformation services with an extensive R&D effort supported by EU-funded projects. All of our projects focus on developing cutting-edge prototypes, and our field expertise is in crisis management, cybersecurity, education, healthcare, water management, smart factories, democratic governments, maritime, transportation, and mobility. So, briefly going into the presentation, according to WEF, a big percentage of 65% of children entering primary school today will work in jobs that don't exist yet. If we actually think about that, it's something that can be also a bit terrifying, thinking that only if there's going to be such a big change in how the workforce actually works. And we can even see that because even a decade before, there are things that we're doing now every day in our lives that weren't even comprehensible a decade ago. So regarding education, something that we have to consider is how can we make learning more engaging, personalized, and effective? Education, unfortunately, and fortunately maybe, must adapt to keep up with the evolving careers and the technologies. There are still, of course, some challenges that remain, and some of them we can mention that the learning methods are rapidly evolving due to the digital transformation. So education, some challenges in traditional education can be that one size fits for all approach that we usually have in classrooms, lack of engagement from the students, and at the same time limited accessibility. And there are emerging technologies right now like XR and AI, which offer new ways to enhance learning. It's quite important to focus on human-centric design because technology should empower educators and learners and not try to replace them. So, just to explain a little bit more, how AI and XR address gaps in traditional education. AI and XR address gaps in traditional education by providing personalized, immersive, and interactive learning experiences. The AI adapts the content to individual students. It offers customized learning paths and real-time feedback. It can automate the grading and the tutoring, and it can reduce the workload on teachers while improving student engagement. While XR can enhance the hands-on learning by allowing students to explore virtual environments, conduct simulation, and engage with educational content in a highly interactive manner. Together, these technologies make education more accessible, engaging, and tailored to diverse learning needs. We have to stress that human-centric design keeps students and educators at the core of the innovation. We should emphasize that human-centric design ensures that technology serves as a tool to enhance the learning experiences rather than replace the traditional educational roles. It prioritizes students' individual needs, the learning styles, and the accessibility requirements, while at the same time empowers educators with AI-driven insights, automation, and immersive tools that support rather than substitute their own experience. This way, by keeping students and teachers at the heart of the innovation, AI and XR foster a collaborative and adaptable learning environment that improves the engagement and the outcomes. I have already mentioned a little bit about XR, but for someone who doesn't know what XR is, let's break it down a little bit. So technically, the VR, virtual reality, AR, augmented reality, and MR, mixed reality, are key components of XR, the extended reality. It offers a unique educational benefit. VR can create a fully immersive digital environment that isolates the user from the real world. And in education, VR can enable virtual field trips, historical recreation, medical simulation, in scenarios that students can practice skills in a risk-free setting. AR overlays digital content onto the real-world environment using devices like smartphones or AR glasses. And AR enhances the traditional learning by adding interactive 3D models, such as viewing the human anatomy layers in biology or seeing historical structures overlaid on present-day locations. Lastly, the MR blends real and virtual elements where digital objects interact with the real world in real time. MR is used for collaborative learning, such as students manipulating 3D holographic molecules in chemistry class. By leveraging these technologies, education becomes more interactive, engaging, and tailored to various learning styles. As an example, we can think for a history class where students can walk through ancient Rome instead of just reading about it. At the same time, we have to highlight the accessibility that these technologies provide, as XR can bring practical learning to students worldwide. So when we want to improve how using these tools can improve the student engagement, AI can adapt learning materials to each of the students' needs. We all know that students have different needs, and sometimes the educator is not able to create different lesson plans for each individual student. AI can assist in that. We can discuss the time saving benefits for educators in creating the lesson plans, but also even summarizing things, trying to explain them in a different way that they are used to. At the same time, we can even have automatic grading and feedback. We can reduce the teacher workload. The AI-powered tutors and chatbots can provide 24/7 student support. And lastly, the generative AI, we can see that it can create quizzes, lessons, and study guides. For example, we can even think of AI chatbots helping students ask questions in real time. Some of the key benefits for all these elements is the personalization, because we can create tailored learning paths, the efficiency as it automates repetitive tasks, and lastly, the scalability, which reaches a larger student group. So moving forward, we should focus a little bit, as the presentation mentioned, in AI and XR, which can be the future of learning content. How AR personalizes XR experiences for students. The AI and XR together create a dynamic, adaptive, and highly engaging learning environment. The AI can personalize XR experiences by analyzing a student's learning style, pace, and interaction with individual environments. And here is an example of how it can work. Real-time adaptation. The AI can track a student's progress, adjusting the difficulty of tasks in XR environments based on their performance. We can have customized learning paths, as AI can assess the strengths and weaknesses of a student, tailoring the XR experience accordingly. For example, a student struggling with a concept in physics might receive additional XR simulation focusing on that area. At the same time, we have to consider that basically we have an intelligent assistant. The AI-powered virtual tutors within XR environments can provide real-time explanation, hints, or feedback when a student makes any mistake. At the same time, we should think that we also have the voice and gesture recognition. AI can interpret voice commands and gestures, making interactions within the XR environment more intuitive. As for the predictive analytics, AI can identify patterns in students' learning behaviors, predicting potential struggles and offering preemptive support. What we can think in a more practical way, as an example, we can think of a VR chemistry lab with the AI integration. We can imagine a virtual chemistry lab where students can conduct experiments in a risk-free environment. Let's see how AI in XR can enhance the experience. The AI can be a virtual lab assistant. It can guide the students step by step as they perform the chemical reactions, offering real-time feedback and correcting the mistakes before they happen. We can have adaptive experimentation. If a student struggles with balancing chemical equations, AI can detect this and present additional interactive exercises, and it can provide instant feedback and assessment. At the same time, all of this is provided in enhanced safety and error correction, as it can prevent dangerous mistakes by alerting students if they're about to create something unsafe and reinforce safety concepts in a controlled setting. Something that is always good to consider is that we can provide this through gamification and engagement, so it can be more interactive. This way, students stay more motivated at the same time. By integrating AI and into XR, students receive personalized guidance, allowing them to learn through trial and error in an immersive and risk-free setting. Some of the challenges, of course, that we should consider is that we should ensure inclusivity in AR-driven XR education, because while AI and XR provide immense benefits, they also come with challenges, particularly in the accessibility and the ethical concerns. For example, we have to consider that not all students have access to XR hardware and AI-powered tools. Or there are schools in underprivileged areas that may lack the infrastructure to support high-end XR experiences. At the same time, something that is new, and of course we always have to take into consideration, is the AI bias and the fairness. AI models can be trained on data, and if that data lacks diversity, bias can creep in. Developers must ensure that AI is inclusive and culturally diverse to accommodate different educational needs. Lastly, of course, something that is quite important is the teacher training and the resistance to change, because as we mentioned at the beginning, it's something that teachers usually fear, that these tools are here to replace them instead of help them. Lastly, something that we should also mention is the privacy and ethical consideration, as there are still some data protection policies that we need to be taken into consideration before moving forward. As a final thought for this part of the presentation, AI and XR have the potential to transform education, making learning personalized, engaging, and accessible. However, there are some challenges that need to be addressed related to accessibility, ethics, and teacher readiness, which are the key to ensuring inclusiveness, high-quality education for all students. Based on everything that we have already presented, I'm going to give a little bit of an overview of the two projects that we are implementing, which are taking advantage of exactly these tools. The first one is HECOF, a higher education classroom of the future. HECOF initiative wants to create a systematic change through fostering innovation in higher education teaching practice and national reforms in education. It achieved this by developing and testing an innovative, personalized, adaptive way of learning that exploits the digital data from students' learning activity in immersive environments and uses computational analysis techniques from data science and AI. Currently, this project is almost at its end, as it finishes this June. And what we recently did is two pilot studies in two universities, one in Athens, the NTUA, and one in Italy, Milan, Polimi, the Polytechnic University of Milan, where there were created two different modules that were targeted to university students to help them conduct specific experiments and learn more about how to run some specific tests in a safe environment. The focus, of course, was to address the ethical and legal concerns around AI in education. That's why this collaboration is with two universities, one in Italy and one in Greece. As for HECOF's impact, we can see that for the students' benefit, we have seen an increased motivation and engagement through the personalized learning. We have enhanced self-directed learning, problem solving, and communication skills, improved interest and competencies in chemical engineering. For the teachers, we can see the professors enhance digital competence and better tracking of student progress, as we have also created a platform during when the teachers visit can see the progress of the students, their assessment, and see areas where they can help them. At the same time, there's also a theoretical background that students can check and reinforce their knowledge. And we have a reduced administrative burden through automated support. As for the broader impact, we have to consider that there is a drive systematic change in education by promoting AI for personalized learning. There's influence policy at EU and national levels, and we can share some evidence on ethical AI application in education. The steps that were taken for the project at the beginning was requirement analysis and privacy, social and ethical impact assessment. We made sure that everything that was later developed on the project was followed by strict ethical assessment. There were some instructional strategies and assessment design. Then we create the agile development of the HECOF system. As I mentioned recently, we finalized the pilot test, the evaluation and the impact assessment. And of course, we're going to disseminate and exploit all of the results of the project. In May 22nd, we're also going to have the final conference in Brussels, where we are going to present all of the results of our project, and the universities will also have the experience to share. They will have the opportunity to share their experience with the students and how the whole process helped in promoting the specific modules. The last project that I'm going to present is GenAI for ED, and this is a relatively new project. GenAI for ED started last October, and it's going to last 3 years. And its main scope and aim is to build a platform for assessing and bridging the generative AI and human skills in secondary education. What this project is about to do is to advance understanding of the psychological, social, and ethical aspects of GenAI in secondary education, try to equip teachers, students, parents, and guardians with digital skills, and promote their responsible GenAI use. The focus areas are the interdisciplinary research, which we're going to analyze the AI impact on secondary education. We, of course, are going to have a student-centered approach, and all of this is, again, to support the educators. This is going to help teachers master GenAI tools and ensure their well-being and work-life balance. Lastly, of course, parents and guardians are always important, so we want to involve parents and guardians in understanding and shaping AI's role in education. As for GenAI for the vision and the technological solution, firstly, we're going to build a platform. It's going to be a dynamic platform for students, teachers, parents, and guardians to explore, understand, and responsibly integrate GenAI tools in education. At this point, we are finalizing the taxonomy, and we are doing a desk and field research on the usage of GenAI tools in education. And the platform will serve more or less as a library in which there's going to be a collection of GenAI tools that can support education. We have the policy development. First of all, some guiding policies which are going to provide actionable recommendations for responsible GenAI use in teaching and learning. We're going to have evidence-based understanding, so we're going to improve insights into the impact of GenAI in secondary education. And as for GenAI for ED's vision, it's going to be a human-centered AI, which is going to foster inclusive, adaptive classrooms using GenAI tools rooted in European values of inclusion and resilience. We're going to have some pilot programs, so there are going to be a rollout pilots in schools to test the platform with feedback from all the target groups. And there are going to be some navigating opportunities to help stakeholders evaluate and understand the opportunities and challenges presented by GenAI tools. Lastly, there's going to be policy support. We're going to develop policies to guide the responsible use of GenAI in classroom and ensuring collaboration between technology and human skills. We're going to focus on coordinating key project activities in the first steps of the project, including reviewing and categorizing AI tools and defining the specification for the platform. Moving forward, we will explore the ethical, social, and legal implication of integrating generative AI into secondary education. So we will need to address critical issues related to organizational, ethical, and policy frameworks, ensuring responsible and equitable implementation of AI technologies in educational settings. And we're going to focus on enhancing educational experiences by designing a real-time dialogue interface for dynamic collaboration, a public feedback system for user input, and a data analytics dashboard for user insights. Lastly, we're going to build the GenAI for ED platform with strong emphasis on technical excellence, security, and privacy. And this will include requirement analysis, architecture and UI UX design, backend development, tool integration, and rigorous testing. The result will be a secure, user-friendly platform that meets ethical, regulatory, and educational standards, enhancing the experience and for teachers and students. At the same time, the execution of pilot use cases in educational settings will assess the impact and the effectiveness of the GenAI for ED platform and its AI tools in higher education. The insights from this evaluation will inform policy recommendations, shaping an enhanced role for educators and fostering innovative practices in education. Summarizing and closing with this slide, the future of learning is immersive, intelligent, and human-centered. And this is something that we are shaping right now. XR and AI are transforming education. AI personalized learning and XR makes it immersive. And we have some examples like projects like HECOP and GenAI for ED, which can lead this new transformation. I would like to thank you very much for your time. And if you want to learn more about the projects, here are both of the links for the project websites. And if you want to learn more about Connectable and what we're doing, this is also a link for our website as well. Thank you very much.
Thank you, Epaminondas, for the presentation. Are there any questions to Epaminondas? Otherwise, we can move to Niall for the last presentation of the day. Are there any questions to Epaminondas? Please, Epaminondas, please do share if this event in May 22nd is open. Please do share information about this in the cluster. It's in Brussels, so a lot of people might be able to attend.
Of course, we're going to share information once we have booked the venue, because we are in the process of booking the venue right now. Okay. And we're going to share information once we have everything, and it's going to be, of course, open. It's you're going to have the opportunity to either attend physically, or you can also participate online. So we're going to share more information once we finalize the final details of this plan.
Excellent. Thank you very much.
Thank you.
Niall, please, the floor is yours.
Thank you.
One has to be last. Sometimes it doesn't mean, the order will be shuffled. Next time, feel free to take the time, introduce yourself and your project.
Okay. So you can see my screen okay there?
Yes, we can see it. Great.
Thank you. Yeah. So my name is Niall Murray. I'm an academic in the Technological University Shannon in Ireland. I'm also a funded investigator in the Research Ireland ADAPT Centre. And I want to thank the organisers for inviting us to give the talk at this session. It's actually been really interesting, and I see a lot of commonality and a lot of kind of common interests between the different projects. Particularly of interest to me personally is around the kind of adaptive content creation in XR. This is particularly interesting. But today I'm here to talk about the Rising Euro project called Transmixer, which I coordinate from Athlone in Ireland. So I'm going to give a brief overview of the Transmixer team, so you get a feel for who's involved in this, what the focus of the project is at a kind of macro level. Then I'll talk in a bit more detail about how Transmixer is a human-centric project and how we're trying to develop XR tools, technologies, and experiences, particularly for the creative and cultural sector. We will talk a little bit about how we engage with different stakeholders and how we got the kind of inputs from these different stakeholders, how we develop the technology, with the key stakeholders from the creative and cultural sector centered around this. And then I'll give some examples of some of the different technological components and how they're being applied within the different use cases in Transmixer. So we have a really nice team in the project. We're 22 partners from 12 countries. And we have a nice balance of kind of industry, academic on the technical side. And we also have 7 use case leads, which we'll classify as media practitioners across the areas of news broadcast, news media, cultural heritage, and the performing arts. We're in innovation action, so our job is to produce ITRL level technologies at the end of this. We're a project that's going to run for 39 months, and our key priority within the cluster call is to support the development of advanced solutions for creation, consumption, and distribution of new media products, including XR. So like all these kind of projects, we had kind of these high level objectives at the beginning. There's a kind of a couple of key words that are really important in this text here. They are kind of defining and producing novel workflows for the creative and cultural sector with XR, new formats that are cross-platform. And then we kind of had 3 technical objectives around sourcing content, which is where we're trying to find content. We use AI techniques a lot for this, and then we're trying to develop tools as part of the creation of content. This is in a collaborative manner, but it's also tools for conversion of, let's say, 2D assets into 3D content. And then, of course, to deliver immersive experiences, which have been talked about across the other projects, and how do we make this personalized to enhance engagement and these kind of things. And then once we have successfully achieved this, what we're trying to work on now, actually this stage in the project almost, is how we kind of bring the Transmixer technology components and workflows to the CCS specifically, but then target other kind of domains outside of CCS as part of our transferability aspect. So really in Transmixer, because there's lots of projects who work around this area, and really in the project, one of the key things we've tried to differentiate ourselves from is to look at these technologies through the eyes of the CCS. So we're not, even though we have lots of, technical partners, we're really trying to look at this from where XR and AI technologies can bring value to CCS through the eyes of, the journalists, through the eyes of performing artists, cultural heritage, and so on and so forth. So we're a big team, but we're very intertwined in how we work. And this kind of slide reflects quite well our iterative and incremental approach. We adhere strictly to the Live in Labs methodology, which is defined by our social science partner, VUB. And throughout the project, we've had kind of key milestones where we have developed POCs, we showed POCs, and we've got feedback on the POCs. So this has worked quite well, and we're kind of converging now towards quite mature prototypes that we will use for the final evaluations in the project. So as part of our stakeholder engagement, we have interacted with more than 360 professional and end user groups across a range of different workshops. And this is, as I said, facilitated by our Live in Lab approach. But really, this was with journalists talking to other journalists, trying to understand their problems with technical partners who have expertise in the technology, to see where the sweet spots are, or to see where there are gaps that AI technologies and XR technologies within CCS can support them. So we had a significant 13 workshops with professional and end user requirements. We also spoke then with XR production studios to try and understand what, from their point of view, if they have clients coming to them, where the issues were for them. So we did this internally in the project with Cora from Copenhagen, Denmark, Immersion from Bordeaux in France, to try and understand what are the issues they see, right? And this was supported then by significant interviews and surveys, where it became quite clear, and everyone in this call, I'm sure, are aware of this, that there are significant use of common language across different stakeholder groups, which mean completely different things, which cause lots of confusion and lots of challenges. We managed within the project to kind of come into a kind of a consensus in terms of language and understanding, and then we use this to have a suite of design and creative workshops to define what we would actually build based on the requirements. So what we've defined in the project is a suite of workflows which support the CCS, addressing some of the language barriers, but also using emergent technologies to actually help communicate complex concepts, from the creative spaces to the technical space, from the news broadcast, news media space to the technical space, and from cultural heritage into the technical space. And we found that we required some standardization extensions, which were developed as part of the project as well. So in addition to this, so this kind of workflow was workshops, stakeholder engagement, understanding what we needed to do from the workflow perspective, define new standards, and we resulted then in a range of technological components which are modular and reusable within the kind of understanding space or selection space for content, within the creation space for content, and within the experience space. So we're applying these kind of technological components then within the 4 CCS use cases, as I said: news media, news broadcast, performing arts, and cultural heritage. And what I'm going to speak to now is a little bit of a summary of exactly what's happening here in the project, right? So you see here Mate from RTV Slovenia, and in this particular use case, what we're focused on is trying to understand or support the work of journalists with tools to realize new products and experiences. So what you see here is Mate working in his office, and he's going to go to a ski event in Slovenia, the World Championships in Planica. He's going to bring his mobile phone to capture some content. He's going to bring a set of guidelines that were defined as part of Transmixer to help him understand how to capture the content in a way which is suitable for conversion into 3D representations of the content. And in addition to this, he's using the dashboard and other tools to source content. So it empowers him as a journalist to find content quickly, to validate the content, use this content then to create 3D representations. Of course, there's a phase of editing with this that requires some level of kind of technical competence, but it empowers Mate as a journalist to go far beyond, to use these tools rather to create new types of media experiences. So this is in the news media and broadcast, and we're really getting lots of traction in terms of the tools we're developing here across all these different aspects. So you can see that this is Alioza Smolic here from HSLU. This is the content that Mate captured when he was at the ski championships themselves, and they were able to use this then to create an XR representation of the ski event. So this is obviously particularly interesting and particularly useful when we're empowering the journalists. They're not paying XR production studios, every time to do this. We're actually empowering the journalists themselves. So then in the news media use case, we have Immersion leading some work with TG4 in Galway. And what we're doing here is trying to use AI and XR tools to produce a real-time TV program in a role-aware manner, where we can have distributed expertise in terms of audio, in terms of video mixing, in terms of content creation. They can work together in a virtual control room, and they can produce real-time news through this. So we're taking multiple types of inputs, we're analyzing them with the dashboard that we saw in the previous video. We're creating real-time content for volumetric from volumetric capture systems, and then we're outputting XR-based representation of the news, but also in 2D. So this is being tested right now in TG4 in Ireland, over in Galway there, where they're using this tool right now to produce real-time news, and you can see the 3D representations of the journalist here in this. So this is something that can have significant potential for news broadcasters who are on limited budgets to produce real-time news without the need for all this expensive hardware to go to sites to capture the content. So this is, again, is a very applied use of XR and AI tools in news broadcast. So then in performing arts, So we're doing a really exciting immersive theatre piece in performing arts, and within the context of performing arts use case here called Tailweaver, what we're really trying to do is how can we showcase the possibilities of these immersive technologies within the performing arts sector. So Tupac Matir here you see in the video, he works, he's a founder of Satori Studio based out of Lisbon, and what they're doing in this kind of use case is really pushing the boundaries of what is actually technically possible with these technologies. So this use case has a range of different AI-based technologies, mocap, volumetric video, and it's a mixed reality experience. So the installation in Lisbon here, it'll also be trialed in Dublin and in Vilnius in the Baltics. We're going to have a real installation where multiple users, up to 4 users, can together come and experience this. And based on where they interact in this MR environment, they will get a personalized NPC interaction. So this is really challenging in terms of the technical feasibility of this project. But again, the motivation here is to showcase what's possible to the performing arts sector with these kind of technologies. And the last example we have here is with the cultural heritage use case. And what we're trying to do here is have we're calling it data-driven immersive storytelling format for cultural heritage sector. Okay, but the kind of key research question we're trying to address here is how can we democratize immersive storytelling for cultural heritage organizations. So again, we're trying to make sectorial impact here, and we have a couple of different kind of key technology blocks. What we're using is social XR as part of a new workflow for enhanced communication and collaboration. Very early on in this presentation, I talked about language being a barrier for communication between XR production houses and any of the CCS sectors, in fact. So what we're trying to use here is social XR to show examples of what's possible with these technologies, so that as part of the requirements definition for XR experiences, they actually the creative and cultural sector end users actually see what they're actually getting, right? One of the key motivations in this use case also is that every time, we'll say, a cultural heritage organization wants to create an XR experience, they don't have to go back to an XR production studio, right? What we're trying to do here is create a format that allows curators to adapt and change and reuse or reconfigure existing XR experiences with new types of content and new narrative stories. So this can be highly impactful, because we all know one of the kind of barriers around XR experiences and the production of them is the cost. So this is a reusable template for this. So what it means is that you're working in a museum, we'll say in Limerick in Ireland, or over in the Netherlands Institute for Sound and Vision in Hilversum, and you create this XR experience. It's done by a production studio which is based on a template. 3 months later, you want to change some aspects of this, you can switch some of the content on this, you can switch some of the metadata that allows you to update the experience, which we think is really important. And another really important element of this as well is that these archives are huge. They have huge metadata, huge amount of data a huge amount of actually experiences that never see the light of day actually. So we can have metadata representations of these, and it's a new way of showcasing what's in the archives of the cultural heritage sector. So we're really excited about this, as we are with all of the other use cases. So we're in the last year of the project now, so it's going to finish this coming December. And as I said earlier on, we're at the iterative development stage. Pretty much all of the different use cases that I talked about are mature at this stage. So we're doing our final evaluation final evaluations are happening towards end of May, June this year. And we're already ramped up the efforts on capacity building and exploitation, obviously. And at this stage now, we're refining our message towards transmixer products. So all of those technology components can be packaged in different ways. And if you visit our website over the next couple of weeks, you'll see lots of updates around this. And lastly, just where time is up here, so I'll just highlight, we're at the International Journalism Festival in Perugia in Italy in April, and our friends from CWI in Amsterdam are hosting their 3rd iteration of the Spring School on Social XR. So this is really Transmixer. I'd encourage you to follow us on the different social media channels. We're quite active, on these, led by FXS, so Christiana's on the call here, and you'll get lots of information from our newsletter and from the website. So that's Transmixer in 15 minutes. Thank you very much.
Thank you, Niall. Thank you for the presentation, for keeping the time, and for giving really very good content. Are there any questions to Niall? Actually, we have just 1 or 2 minutes. Maybe there is time for a question. In the meantime, while we wait for the question, because you need 8 seconds for a bold guy to ask a question usually. I want to, because these are the last minutes, so I want to thank all the speakers. This is recorded, so we're going to share your presentations. If you want to share with me any updates, please share update presentation. If not, the version I have should be okay. And we're going to share all the information about this webinar, agenda, speakers, presentations, and the recorded stream online, and then through different projects we manage a very good outreach. Moreover, we will be planning in May or June the 5th webinar on another topic. You will be notified soon. And 2 extra activities we will be considering in the cluster is one event on standards, on XR standards and standardization, and maybe for the projects that are already active, in the next month we might consider a joint publication like an open access book. So there is plenty ahead, so stay tuned. And Christiana from FXS has shared kindly the channels of Transmixer, but also we will share the channels of the BeyondXR project. Thank you very much, Niall. No bold people to ask you a question, right? It happens sometimes, but thank you very much. It was really, really very good overview presentation. Thank you so much.
No problem. And just to say, we're very open to collaborations, particularly in the standard stuff. So we've done an extension to GLTF for volumetric video. So we're really open to this. We're working with some other projects as well, funded in our cluster. So I really support these kind of efforts where projects get together to build kind of knowledge across them. Yeah.
Yes, because some of the projects, have commitments for devices, standards, OpenXR, and so on. So it's good to catch up and see where we stand. And this is going to be in the coming couple of months. But what's the end date of Transmixer?
End of December 25.
End of December. Okay. So still enough time to go. Thank you all very much, especially the speakers. And yes, let's keep in touch. Enjoy your afternoon. Bye-bye.